Hello everyone, this video is about operations with radical expressions. This first one is going to be simplifying expressions with the product property. First thing we need to do is take this large radical, and in this case it's the square root, and we're going to split it up into 3. So first I've got this 12, so I have square root of 12. Then we have square root of c to the 6. Then we have square root of d cubed. Now we split it up into each one of these, and they're all going to maintain the same kind of root the original one had. In that case, it was a square root. So I'm going to use a little factor tree to split up the 12. That splits up into a square root of 4 times the square root of 3. Hopefully at this point we know what the square root of 4 is. That's a regular old 2. Square root of 3 doesn't simplify any further, so I'm just going to leave that as the square root of 3. C to the 6th power. We can take the square root of that one. It's a square root. We don't typically write it, but there is assumed to be a 2 out there. How many times does 6 go into 2? Well, that's 3 times evenly. So this ends up being c cubed from that c to the 6th. D cubed, I'm going to do that the same way. I have a d squared in it and then a regular d. So I end up with square root of d squared, square root of d. D squared gets me a regular d, and the square root of d comes down. Now I'm going to put together everything in the order of no square root, and then everything with a square root down by themselves. So 2c and d, 2c cubed, d, square rooted 3, and square root of d. I'm going to put all together and back underneath that square root. So that one's done. This time over here, we're going to do a cubed root. We're going to split them all up. Cubed root of 27, cubed root of y to the 12th, and then cubed root of z to the 7th. Cubed root of 27, well, that 27 is also 3 cubed, or you can think about it just like the cubed root of 27, if that's one you happen to remember. But these 3's are going to make that cancel, so this is a regular 3. This y to the 12th, we're going to treat it kind of the same way. How many times does 3 go into that 12? And that's going to be y to the 4th. Z to the 7th. How many times does 3 go into the 7? Twice. So I'm going to have z squared, but I'm left with, not a y, I'm left with another z underneath the cubed root. I'll write that better, because this splits up into the cubed root of z to the 6th and the cubed root of one more z. That part comes over and gets us z squared, and that part comes straight down. We group up the stuff that has no radical and then the stuff that has radicals. So 3y to the 4th, z squared, and then I still have a cubed root of z hanging out. Alright, next one we're going to go to is simplifying expressions with the quotient property. So I have a square root of both of these things. I'm going to split that up so that they're both square rooted. X to the 6th over square root of y to the 7th. X to the 6th, that reduces even further. That's just the x cubed, because 6 has 3 2's in it. 7, well, how many times does 2 go into 7? 3 times, and then there's 1 y left over. We don't like square roots in the denominator, though, so we're actually going to rationalize this a little bit. I'll talk more about that later, but here we are. I'm going to multiply this by the square root of y, because that is how we're going to cancel this square root. X cubed, and now I have a square root of y next to it. I have a y cubed. Square root of y times square root of y is going to get me a regular y, and then I can combine those two things. Go on to our next one over here. This is the 4th root, so we're going to still split this up. 4th root of 6 over 4th root of 5 over x. This one's going to be a little bit more complicated. I'm going to rewrite this whole thing down here. And I'm actually going to write that 5x in parentheses. What's the current exponent on 5x? Just a 1. I need to multiply that by my same 4th root and it's going to be 5x. But what does that exponent need to be so that it'll eventually cancel with this 4? I want to end with the 4th root of 5x to the 4th. So what does this one here have to be? 4. Now if I start off with 1, I need 3 more. So this is still 4th root now of 6 times 5x cubed. Now we can simplify a couple little things. Still have the 4th root, but it's 6, and what's 5 cubed? That is 125. X cubed all over, and then these we just said, those 4s are going to cancel with each other. So I'm left with 5x on bottom. I could do a little bit more up here. 4th root of 750 x cubed all over 5x. And none of these can come out. None of them have 4 of the same things in them. Only have 3 x's, and the 750, there's not a whole lot of anything going on in there. All right, let's switch that out with our next one. Multiplying radicals. We're going to multiply the stuff that's on the outside, then the stuff that's on the inside. And it's important to note we can only do this when it's the same kind of radical. Both of these are square roots. So 6 times 4, that gets me to 28. Now I'm going to multiply the stuff underneath the radical. 8c cubed d to the 5th times 2c d cubed. Now I can reorder this a little bit because of the commutative property of multiplication. So I'm going to have the 8 times the 2 is 16. C cubed times c to the 4th, and then d to the 5th times d cubed is d to the 8th. When I'm multiplying the same base, I add up their exponents. So 3 plus the 1 on this c gets me 4. 5 plus 3 gets me 8. Now we see if there's anything that can come out. Square root of 16 is a 4. Square root of c to the 4th is c squared. And the square root of d to the 8th is d to the 4th. Because that's how many times does this 2 go into that 8. All right. And 28 times 4 gets me 112. C squared d to the 4th. Next one over here. Again, we still have the same kind of root. They're both 4th roots, so I'm able to multiply them. Multiply their outsides first, 6. Then I'm going to put everything underneath them together. The 8 times 2, well, that's 16 again. X to the 3rd times x to the 5th. I add those exponents because they're the same base. And I have x to the 8th. Y squared times y squared, that is y to the 4th. So it's 6 times 16. Let's see, are there 4 sets of 2's in there? 2 times 2 gets me 4, times 2 is 8, times 2 is 16. 2 to the 4th is 16, so I can pull a 2 out there. X to the 8, how many times does 4 go into that? Twice, so it's x squared. Y to the 4th, 4 goes into that once, so y to the 1st. 12x squared y. And done. Next one, and we're almost done. This one and one more page. So we're adding and subtracting radicals. When we're doing that, we have to make sure that the radical is the same. 8 and 50. They are not the same, so I have to try and simplify this first. So this square root of 8, that can split up into square root of 4 times the square root of 2. We know what the square root of 4 is. That's a regular 2. So I have this 4 coming down. I have this 2. And then that square root of 2. I'm going to do the same thing with the 50. I'm going to try and split it up as best I can. There's a square root of 25 in there times the square root of 2. Square root of 25 is a regular 5. Sorry, square root of 25 is a regular 5. And then there's the square root of 2 I can't do anything with. So the plus comes on down. The 3 comes on down. This 5 comes down. And the square root of 2 comes down. Make sure you don't lose anything as you're kind of going through this. 4 times 2, 8. 3 and the 5 gets you 15. Now both of these are the same. They're both square roots of 2. So I can kind of treat it like an x. 8x plus 15x would be 23x. But in this case, it's the square root of 2. We're going to come over here and do the same thing on this one. 12, does it break up? Well, square root of 4 and square root of 3. Square root of 4 is a regular 2. 27 splits up. Square root of 9, square root of 3. And 128 splits up into square root of 64 and square root of 2. Square root of 9 is 3. Square root of 64 is 8. Don't forget about these front numbers. Well, that one just has a 1. We're going to make sure all of those come down. 5 times 2 times square root of 3. 2 times 3 square root of 3. And this one is a minus 8 square root of 2. Simplify these front terms. So we have 10 square root of 3 plus 6 square root of 3 minus 8 square root of 2. These two are the same. Square root of 3 and square root of 3. So I can add their front numbers together. 16 square root of 3. Just bringing this one down. Square root of 3 and square root of 2. Are they the same? Nope. So I've got to leave it as is. Alrighty, next one is rationalizing denominators. This one can be really tricky, so take your time when you're going through these. Practice them as often as you can. If I have all of this, 3 divided by the square root of 2 plus 1, we don't like square roots in the denominator, so I have to multiply by the conjugate. Conjugate in this case is going to be the same as these two numbers, so I'm going to have the square root of 2 and a 1 on top and on bottom. As long as I do it on top and bottom, then I don't change the actual equation. But instead of plus, I use minus. This is the same thing when we were using imaginary numbers. Make sure you distribute this 3 in. So I have a 3 square root of 2, and I have a negative 3. Then I have to FOIL on the bottom. Square root of 2 times 2 is the square root of 4. Square root of 2 times 1 is a negative square root of 2. That was because square root of 2 times negative 1. Then I have a positive 1 times the square root of 2. That's a positive square root of 2. A positive 1 times a negative 1 is negative 1. You'll notice these two terms are the same, except opposite, so they cancel each other out. That's important. That's what we wanted to have happen. I'm just going to copy down my numerator. And look at the bottom. Square root of 4, well, that's just a 2. Negative 1, I'm just going to bring it down. Well, what's 2 minus 1? 1. And I don't even need to write that I'm dividing by a 1. So that's my answer. And that is it. Hopefully this video was helpful. I'm hoping to put up more videos related to, this is Chapter 6 for my Algebra 2 class. And I hope you watch them, and I hope these are helpful. And if they are, please click that link, that like button that should be down over here somewhere. Have a great day, everybody.